Welcome to the shore of existence itself, where the last photons of creation whisper their ancient secrets into the cosmic void. Tonight, as your thoughts drift towards sleep, we journey to the place where space and time grow thin, where NASA's most powerful instruments have glimpsed something that shouldn't exist, a boundary that defies everything we thought we knew about infinity. What waits at the edge of all that is? And why does its discovery make some scientists question whether we've been looking at the universe backwards all along? Could the universe itself remember its own birth? The answer drifts across the sky as a faint glow, older than any star, older than any galaxy, older even than time measured in the way we know it. It is light that has travelled nearly 14 billion years to reach us, carrying a message from when the cosmos was still an infant. A memory written not in words, but in radiation. This light was born when the universe was just 380,000 years old, a moment so early it is almost impossible to imagine. Before then, space was filled with a blinding plasma of particles, too hot and dense for light to travel freely. Photons scattered endlessly, colliding with electrons, unable to escape. But as the young universe expanded, it cooled. At last, hydrogen atoms formed, the fog of scattering lifted, and light was released to wander into the open. That glow became the cosmic microwave background, a soft afterglow of the Big Bang, still visible today in every direction. For millennia, this background remained invisible to human senses, hidden beneath the ordinary night sky. Yet with delicate instruments, NASA's satellites turned whispers into vision. COBE, launched in 1989, gave us our first blurred image of this ancient light, confirming its existence beyond doubt. It was like the universe revealing its baby photograph for the first time. A decade later, WMAP sharpened the picture, tracing temperature variations across the sky, and finally, the Planck mission refined it to breathtaking detail, showing the universe as a glowing tapestry of ripples and patterns. These ripples are more than mere variations in warmth. They are the very blueprint of structure itself. Tiny fluctuations in density, just fractions of a degree told where matter would one day gather. Over billions of years, gravity would amplify those differences, pulling gas and dust into clouds, clouds into stars, and stars into galaxies. In those slight imperfections lay the seeds of everything, the Milky Way, the Sun, Earth, and even the atoms that now form the breath of those who wonder about it. Without those ripples, the universe would be smooth and lifeless, an endless fog without form. What NASA's instruments revealed was not chaos, but a deep harmony. The map of the cosmic microwave background is not random static. It is a symphony frozen in place. Each tiny wave carries the rhythm of sound rippling through the infant cosmos, acoustic oscillations from a time before stars. To study it is to listen to a cosmic lullaby recorded billions of years ago, a melody of pressure and light woven into the fabric of space. From silence, NASA drew vision. By mapping the faint glow stretched across the heavens, it painted the universe's very first portrait. In its colors lie answers to profound questions: the age of the cosmos, its composition, its destiny. The discovery is humbling, for when we look at this afterglow, we are not gazing outward alone, but backward through time itself, to a moment when light first broke free and the universe began to shine. What if the darkest place in the sky was not empty at all? In 1995, NASA's Hubble Space Telescope was aimed at a patch of space that seemed utterly blank, a region so small it could be covered by the tip of a pencil held at arm's length. Astronomers wondered if this emptiness concealed anything, or if the telescope's stare would return only silence. For 10 days, Hubble gathered light from that one spot, building an image photon by photon. When the data was assembled, darkness bloomed into an astonishing revelation. Across the frame appeared not a handful, but thousands of galaxies, each one a collection of billions of stars. Spirals unfurled their arms, ellipticals glowed softly, and distorted smudges told of ancient collisions. What looked like nothing was in fact an ocean of light, carrying histories from billions of years ago. This picture became known as the Hubble Deep Field. It changed humanity's understanding of the universe forever. For centuries, the night sky seemed scattered with stars that could be counted, their number large but finite. Hubble revealed that the cosmos was far richer. In a patch of sky no larger than a grain of sand, thousands of galaxies crowded together. Multiply that across the whole sky, and the number becomes almost ungraspable. Hundreds of billions, perhaps trillions, of galaxies stretching in every direction. Each faint smudge in the image is not just a light, but a city of suns, many of them already old when Earth was still young. Some of the galaxies in that frame date back to less than 1 billion years after the Big Bang, their light travelling for over 13 billion years to arrive here. To see them is to peer across nearly the entire span of cosmic history. Later, NASA repeated the experiment with even longer exposures, producing the ultra-deep field and the extreme deep field. With each attempt, the telescope revealed fainter and more distant galaxies, pushing the edge of observation closer to the first generations of stars. What once looked like a void became a window into the earliest chapters of creation. The lesson was profound. The universe is overflowing, even in the places that seem most barren. Where the naked eye sees emptiness, the cosmos hides entire realms of structure and story. NASA's Hubble showed that darkness is never truly empty. It is often simply waiting for the right eye to look long enough. From a single blank corner of the sky, humanity learned that the universe is not sparse but abundant, a vast ocean of galaxies without end. Each grain of night carries countless worlds, reminding us that creation fills even the smallest space with wonder. The universe is not static, it is in motion, stretching outward with every passing moment. For much of history, scientists imagined that gravity might one day slow this expansion, pulling galaxies back together in a great reversal. NASA's careful observations revealed a different truth. By studying distant stellar explosions, astronomers uncovered evidence that changed our understanding of the cosmos forever. The explosions they studied were Type 1a supernovae, brilliant endings of stars that shine with nearly uniform brightness. Because their light is predictable, they serve as cosmic markers for distance. NASA's instruments recorded their faint glow across billions of light years, allowing astronomers to trace how far the light had travelled and how quickly the host galaxies were receding. The results defied expectation. Instead of slowing, galaxies farther away were moving faster. Expansion was not fading, it was accelerating. This finding introduced one of the greatest mysteries of modern science: dark energy. Unlike gravity, which pulls matter together, this unknown force pushes space itself apart. It does not reside in stars or galaxies, but in the fabric of the cosmos, acting everywhere at once. NASA's measurements transformed a simple image of expansion into a revelation of a force that dominates the universe, making up nearly 70% of its total content. The consequences of this discovery reach far beyond equations. It means that countless galaxies are already beyond reach, carried away faster than light can bring their messages. As time flows forward, more and more of the universe will slip past the cosmic horizon, vanishing from sight forever. What we see today is only a fleeting view of a much larger reality, a snapshot before the edges drift into silence. Dark energy remains elusive. Some scientists believe it is a property of space itself, echoing Einstein's idea of a cosmological constant. Others wonder if it signals new physics waiting to be uncovered. NASA continues to refine its measurements through galaxy surveys, background radiation maps, and careful analysis of clustering patterns. Each dataset adds precision, but the mystery endures, reminding us that the greatest forces can be invisible. The expanding canvas is still being drawn, stretching wider with every heartbeat of time. NASA's discoveries revealed that the universe will not collapse into an ending, but will continue to open, layer after layer, into horizons we will never cross. At the edge, creation is motion itself. Galaxies racing outward, light stretching thin, space writing its story in ever-widening arcs. What once was thought to be still is now known as eternal flight, a canvas unfolding endlessly into the unknown. Galaxies spin with such speed that their stars should fly apart, scattering into the void. The visible matter stars, gas and dust, is not enough to hold them together. Yet they remain bound, their spirals intact, their clusters united. NASA's instruments revealed that something unseen provides the necessary gravity, an invisible framework shaping the cosmos. This hidden presence is called dark matter, and though it cannot shine, it is the silent architect of structure. Hubble's observations showed arcs of starlight bending where no visible mass existed. Background galaxies appeared stretched and distorted, their paths curved by gravity from something unseen. This effect, known as gravitational lensing, became a powerful tool. By studying these warped images, NASA traced halos of dark matter surrounding galaxies and clusters. What the eye cannot see, the light itself revealed through its bending. Chandra's X-ray vision provided further proof. By observing the hot gas within galaxy clusters, astronomers measured its distribution and compared it to the cluster's total mass. The visible gas accounted for only a fraction of the gravity holding the cluster together. The rest belonged to the hidden skeleton, vast reservoirs of dark matter enclosing and binding everything within. Together, Hubble and Chandra showed that galaxies are mere lanterns strung along invisible threads. Further surveys extended these findings, mapping filaments of dark matter stretching across cosmic space. These filaments weave galaxies into the grand design known as the cosmic web, a network that spans hundreds of millions of light years. The luminous universe, stars, nebulae, and galaxies, rests like dew upon its strands, shaped by an architecture that remains unseen. NASA's data turned darkness into a map, charting what cannot be observed directly, but whose influence is undeniable. Despite its overwhelming presence, dark matter remains one of the greatest mysteries in science. It does not emit or absorb light. It does not interact with ordinary matter in familiar ways. Yet its fingerprints are everywhere, in the rotation curves of galaxies, in the stability of clusters, in the arcs of bent starlight. Without it, galaxies would unravel, and the large-scale structure of the universe could never have formed. NASA's discoveries revealed that most of the cosmos, nearly a quarter of its total content, is made of this invisible matter. What we see, the stars and galaxies that sparkle in the night, is only a small fraction of reality. The rest lies in shadows, shaping the universe silently. In every galaxy's graceful spin, in every cluster's enduring strength, the unseen hand of dark matter holds its place. NASA's eyes uncovered this truth, proving that even in starlight, the shadows carry the greatest weight. The universe bends light in ways that transform emptiness into revelation. When starlight passes massive clusters of galaxies, the pull of gravity curves its path, bending it as though space itself were glass. NASA's Hubble Space Telescope captured these distortions, delicate arcs of light, rings that circle invisible centers, and galaxies stretched into luminous smears. These shapes are not errors in vision, but confirmations of Einstein's prediction that mass curves space-time. What began as a theory became a tool. The phenomenon is called gravitational lensing, and it turns the universe into its own telescope. Clusters of galaxies, containing vast amounts of both visible and dark matter, magnify the light behind them. Distant galaxies, otherwise too faint to detect, suddenly become visible when their light is bent and brightened. NASA's images showed that nature itself provides magnifying glasses, lenses sculpted not by glass and metal, but by the very fabric of space-time. Some of the most striking examples are the Einstein rings, perfect circles of light, formed when a distant galaxy aligns precisely behind a massive foreground object. These glowing halos are more than curiosities. They are natural laboratories. By studying them, NASA astronomers measure the distribution of dark matter, map the weight of clusters, and peer deeper into the early cosmos. Each arc, each ring carries hidden information about both the lens in front and the galaxy behind. Through these warped mirrors, Hubble reached further back in time than ever before. Galaxies less than 1 billion years old, their light stretched thin across 13 billion years of travel, came into view. These glimpses showed the universe when it was still young, assembling its first clusters of stars and dust. Without gravitational lensing, such galaxies would remain invisible, their light too faint to reach us directly. With it, NASA turned distortions into doorways, each arc a portal into the past. These images are reminders that even in bending, light tells the truth. The arcs and rings are not flaws in vision, but gifts of geometry, where space and gravity reveal more than they hide. Each distorted galaxy is a message carried across time, a hidden letter from the dawn of structure. NASA's discoveries showed that the universe itself collaborates in its unveiling, using gravity not only to bind but to magnify. In every ring of light, in every arc stretching across the darkness, lies proof that the cosmos is both elegant and generous. What began as a distortion became one of astronomy's greatest tools. NASA's eyes turned these hidden lenses into windows, and through them, humanity glimpsed the earliest chapters of time, messages magnified by the universe itself. The universe is filled with echoes, faint signals from ages so ancient they seem almost beyond reach. NASA's satellites, cooled to near absolute zero, became instruments tuned to listen for these whispers. Among them was the cosmic microwave background, the afterglow of the Big Bang. With delicate precision, missions like COBE, WMAP, and Planck mapped its patterns across the entire sky. What appeared at first to be a uniform glow revealed itself to be speckled with tiny variations, fluctuations no larger than a fraction of a degree. These were not random. They were the seeds of all structure, the first hints of galaxies taking shape within the newborn universe. But the cosmic microwave background is only one part of a larger choir. Other voices resonate just as softly, waiting for instruments sensitive enough to hear them. Ghostly neutrinos, particles that barely interact with matter, stream through the cosmos in numbers beyond counting. They are relics from the early universe, survivors from moments when matter and energy were nearly indistinguishable. Though almost impossible to detect, NASA has worked with ground-based observatories to trace their presence, adding another voice to the chorus of creation. Gravitational waves provide yet another note. Predicted by Einstein and confirmed a century later, these ripples in spacetime come from cataclysmic collisions, black holes merging, neutron stars spiraling together. NASA's partnership with detectors on Earth allowed these vibrations to be recorded for the first time, adding sound to the universe's story. Unlike light, which can be blocked, gravitational waves pass unhindered, carrying direct information about events hidden from ordinary telescopes. Each detection is a new verse in the song of the cosmos, proof that even the fabric of space itself can sing. Together, these backgrounds form a layered symphony. The microwave background is the steady hum of infancy, neutrinos add the faintest of undertones, and gravitational waves bring deep resonant notes of cosmic drama. NASA's role has been to tune this orchestra, refining the instruments so that whispers become knowledge. What was once silence has become harmony, each signal aligned with the next, to tell a unified story of origins. In listening to these ancient echoes, NASA revealed that the universe is never truly quiet. Every age leaves behind a trace, whether in light, particles, or the trembling of spacetime. To map these traces is to build a history of existence itself. The choir of backgrounds reminds us that creation does not fade. It lingers, carrying memory across eternity. NASA's discoveries transformed these whispers into a cosmic hymn, a lullaby sung not by stars or galaxies, but by the universe itself, remembering how it began. Among the most iconic images ever captured is one that looks like a cosmic cathedral, vast columns of gas and dust rising like towers in space. Hubble's cameras revealed these structures inside the Eagle Nebula, naming them the Pillars of Creation. Within their shadowed depths, stars were being born. Clouds of hydrogen collapsed under gravity, glowing faintly as nuclear fires. Ignited deep inside, NASA's instruments showed that even now, billions of years after the universe began, creation continues. The cosmos is not finished. It is still writing itself in starlight. Dust often hides these nurseries from human eyes, but infrared instruments pierce the veil. By looking at longer wavelengths, NASA telescopes exposed newborn stars cocooned in their clouds. These glowing points of light are suns in their infancy. Some, only a few thousand years old. Watching them is like glimpsing the earliest breaths of a star's life, moments that will shape entire solar systems. Just as galaxies once assembled from primordial gas, so too do they remain alive with new generations of stars, factories constantly forging light. The process within these nurseries is both delicate and immense. Gas collapses, pressure rises, and fusion ignites. In those cores, the simplest element, hydrogen, is transformed into helium. Over time, heavier elements form: carbon, oxygen, nitrogen, iron. These are the building blocks not only of planets, but of life. NASA's telescopes revealed that stars are not just ornaments of the night sky, but cosmic furnaces, manufacturing the ingredients that fill every living cell. Death plays a role, as well as birth. Massive stars live fast and end violently, exploding in supernovae that scatter their enriched contents back into the galaxy. This cycle ensures that each new generation of stars is born from material seeded by the old. NASA's observatory has captured glowing remnants of such explosions, showing shells of gas expanding across space. The cosmos recycles itself, and every atom of oxygen we breathe, every particle of calcium in our bones, was once forged inside a star. By peering into these nurseries, NASA uncovered the ongoing artistry of the universe. Galaxies are not static museums of ancient light. They are living ecosystems, vibrant with growth and renewal. In each glowing cloud, in each filament of dust, lies the promise of stars not yet seen, worlds not yet formed, and stories not yet lived. The pillars of creation are more than a beautiful image. They are a reminder that the cosmos is still building, still creating, still offering the raw materials from which future life will rise. At the centers of galaxies lie regions so powerful that even light cannot escape. For decades, black holes were imagined as silent erasers, swallowing anything that ventured too close. NASA's Chandra X-ray Observatory changed that picture. With its high-energy vision, Chandra looked into the hearts of galaxies and found not silence but brilliance. Matter spiraling inward was heated to millions of degrees, releasing X-rays before it vanished into the event horizon. Black holes, once thought invisible, became among the brightest objects in the universe when seen through NASA's eyes. These observations revealed how dynamic and violent the surroundings of black holes can be. As gas and dust fall inward, they form an accretion disk, a whirling structure spinning at near-light speeds. Friction within the disk heats the material until it glows in X-rays, creating a beacon visible across cosmic distances. Chandra's discoveries showed that black holes are not just voids of consumption, but engines radiating more energy than entire galaxies. The paradox is striking. Regions defined by darkness announce themselves in floods of light. Even more astonishing are the jets. Some black holes eject streams of particles and radiation that stretch thousands of light years, piercing through the galaxy that surrounds them. NASA's telescopes captured these immense structures, shaped by magnetic fields and powered by gravity itself. These jets can regulate star formation by blasting gas out of galactic centers, slowing the birth of new stars. Far from being passive consumers, black holes actively sculpt the galaxies they inhabit. Chandra's work, combined with Hubble and radio observations, revealed supermassive black holes at the center of nearly every large galaxy. These giants, millions or billions of times the Sun's mass, anchor galactic cores. Their influence extends far beyond their event horizons, affecting the growth, structure, and fate of entire star systems. NASA's findings transformed black holes from exotic curiosities into essential components of cosmic architecture. The story they tell is one of balance. Black holes consume, but in doing so, they release energy that shapes their environment. They erase, but they also create, guiding the evolution of galaxies across billions of years. What once seemed like cosmic destroyers are now recognized as regulators, keeping the universe's structures in motion and in check. Through the vision of Chandra and its companions, NASA revealed the truth. Black holes are not empty silence, but roaring engines of energy. They remind us that in the universe, Even darkness has power to build. The galaxies we see, their spirals, clusters, and glowing arms, owe their form not only to the light of stars, but to the unseen architects at their centers. For centuries, astronomy was limited to sight. Telescopes gathered light in many forms: visible, infrared, X-rays, but always as vision. Then came a new sense, one that did not depend on light at all. In 2015, detectors on Earth heard something extraordinary: a tremor in space-time itself. Two black holes spiraling together 1 billion years ago had merged, releasing more energy in a moment than all the stars in the observable universe. That energy traveled not as light, but as gravitational waves, ripples expanding through the fabric of reality until they reached Earth. These waves are unimaginably faint, stretching and compressing distances by less than the width of a proton. Yet with exquisite instruments, scientists could record them. NASA played a vital role, supporting the ground-based detectors of LIGO and Virgo with satellite missions that provided essential context. Working together, they confirmed the first direct detection of gravitational waves, transforming theory into observation. What Einstein had predicted a century earlier was now part of the data of human experience. The significance is profound. Gravitational waves allow astronomers to study events hidden from light: black hole mergers, neutron-star collisions, and even echoes from the first fractions of a second after the Big Bang can be explored through their vibrations. Unlike photons, which can be absorbed or scattered, gravitational waves pass almost unhindered across the cosmos. They carry information directly from the heart of cataclysmic events, untouched by the obstacles that block ordinary sight. NASA's involvement extends to future missions as well. Plans for LISA, the Laser Interferometer Space Antenna, envision detectors in space, orbiting the Sun in formation. With arms millions of kilometers long, they will be sensitive to lower frequency waves, opening a new window into cosmic phenomena. Where Earth-bound detectors hear collisions of stellar mass black holes, LISA will listen for the slow, deep rumbles of supermassive black holes merging at galactic centers. The discovery of gravitational waves created a new way of knowing. For the first time, the universe could not only be seen but also heard. Space revealed itself as a medium alive with motion, carrying songs of events once thought silent. When black holes collide, space-time itself vibrates. When neutron stars spiral together, reality trembles like the surface of a drum. NASA's collaborations prove that even emptiness is not still. The void can ripple, the fabric of existence can sing. Each new detection adds a note to the cosmic symphony, deepening our understanding of how the universe evolves. Through gravitational waves, astronomy gained not just another tool, but another sense, one that listens to reality itself. When the James Webb Space Telescope unfolded its golden mirrors in the quiet of deep space, it became humanity's newest eye on the universe. Built by NASA with international partners, Webb was designed to see further than any telescope before it, reaching into a time when the first stars were just beginning to shine. Its infrared vision allowed it to pierce through dust and catch light, stretched thin by billions of years of cosmic expansion. What it revealed was breathtaking. Galaxies older than 13 billion years, their faint glow carrying us to the very edge of time. This era is known as the Cosmic Dawn, the period when the first luminous structures emerged after the universe's long dark ages. For hundreds of millions of years, space was filled with hydrogen gas, transparent yet unlit. Then gravity gathered matter into the first stars, brilliant giants that lived fast and died young. Webb's images showed that galaxies were already forming far earlier than expected, some just a few 100 million years after the Big Bang. Their presence rewrote assumptions about how quickly complexity could arise in the young cosmos. The light Webb captures is ancient and fragile. Stretched into deep red wavelengths by the expanding universe, it arrives as whispers from a time when galaxies were tiny, irregular, and raw. Through its sensitive detectors, Webb transformed these whispers into vivid portraits, showing clusters of stars assembling, clouds of gas collapsing, and the first elements beyond hydrogen and helium beginning to appear. Each image is not just a snapshot of a galaxy, but a page from the universe's early diary, preserved in starlight. NASA's mission did more than extend the horizon. It opened a new era of discovery. By measuring the light from these primordial galaxies, astronomers can determine their age, composition, and rate of star formation. Webb revealed that some were producing stars at astonishing speeds, far beyond what theory had predicted. Others showed hints of heavier elements already present, suggesting that even in its infancy, the cosmos was evolving with surprising efficiency. Every deep field image from Webb is a reminder that the universe was alive with creation much earlier than imagined. Galaxies flicker into view that once seemed impossible to detect, stretching human vision back toward the beginning. NASA's Golden Telescope is not simply an instrument, it is a time machine, carrying our gaze to moments when darkness first broke, when the cosmic dawn painted the sky with its first light. The edge of the observable universe moved closer to its beginnings through Webb's vision. What had once been invisible, hidden in dust, lost in faintness, became real. The cosmic dawn is no longer a mystery wrapped in theory. It is now visible, a shimmering horizon where the first galaxies lit the path forward, revealed by NASA's newest eye on the deep. When the James Webb Space Telescope unfolded its golden mirrors in the quiet of deep space, it became humanity's newest eye on the universe. Built by NASA with international partners, Webb was designed to see further than any telescope before it, reaching into a time when the first stars were just beginning to shine. Its infrared vision allowed it to pierce through dust and catch light, stretched thin by billions of years of cosmic expansion. What it revealed was breathtaking. Galaxies older than 13 billion years, their faint glow carrying us to the very edge of time. This era is known as the Cosmic Dawn, the period when the first luminous structures emerged after the universe's long dark ages. For hundreds of millions of years, space was filled with hydrogen gas, transparent yet unlit. Then gravity gathered matter into the first stars, brilliant giants that lived fast and died young. Webb's images showed that galaxies were already forming far earlier than expected, some just a few 100 million years after the Big Bang. Their presence rewrote assumptions about how quickly complexity could arise in the young cosmos. The light Webb captures is ancient and fragile. Stretched into deep red wavelengths by the expanding universe, it arrives as whispers from a time when galaxies were tiny, irregular, and raw. Through its sensitive detectors, Webb transformed these whispers into vivid portraits, showing clusters of stars assembling, clouds of gas collapsing, and the first elements beyond hydrogen and helium beginning to appear. Each image is not just a snapshot of a galaxy, but a page from the universe's early diary, preserved in starlight. NASA's mission did more than extend the horizon. It opened a new era of discovery. By measuring the light from these primordial galaxies, astronomers can determine their age, composition, and rate of star formation. Webb revealed that some were producing stars at astonishing speeds, far beyond what theory had predicted. Others showed hints of heavier elements already present, suggesting that even in its infancy, the cosmos was evolving with surprising efficiency. Every deep field image from Webb is a reminder that the universe was alive with creation much earlier than imagined. Galaxies flicker into view that once seemed impossible to detect, stretching human vision back toward the beginning. NASA's Golden Telescope is not simply an instrument, it is a time machine, carrying our gaze to moments when darkness first broke, when the cosmic dawn painted the sky with its first light. The edge of the observable universe moved closer to its beginnings through Webb's vision. What had once been invisible, hidden in dust, lost in faintness, became real. The cosmic dawn is no longer a mystery wrapped in theory. It is now visible, a shimmering horizon where the first galaxies lit the path forward, revealed by NASA's newest eye on the deep. The night sky may feel infinite, but NASA's telescopes have shown that our view has limits. As space expands, distant galaxies drift away, carried on the flow of the universe itself. Some move so quickly that even light, the fastest thing in existence, can never reach us. They slip beyond what is called the cosmic horizon, a boundary not of matter or walls, but of time and distance. Beyond it, the universe continues, but forever beyond perception. Hubble's deep surveys first hinted at this truth. By measuring the redshift of galaxies, the stretching of their light into longer wavelengths as they recede, astronomers realized that more distant galaxies were racing away faster than expected. Later observations, combined with NASA's supernova data, confirmed that expansion is not slowing but accelerating. The farther we look, the faster galaxies retreat. Many of them have already crossed the line where their light can no longer catch up to us. For those worlds, what we see now is the last message they will ever send. This discovery reshaped how astronomers think about the universe, the observable cosmos, the sphere of space from which light has reached us since the Big Bang, is not the full universe. It is only a temporary window. Every day, the horizon changes. Some galaxies drift into invisibility, while others remain just barely within reach. NASA's instruments revealed that the night sky we know is a fleeting image, a view destined to fade with time. The idea of horizons is not unfamiliar. On Earth, the horizon is simply the limit of what we can see, not the end of the world. In space, the principle is the same, though on scales far beyond imagination. Horizons are not barriers. They are shifting edges of perception. They remind us that what is visible is only a fraction of reality, and that the universe does not end where our sight does. Future missions continue to refine these boundaries. By measuring the distribution of galaxies, the pattern of background radiation, and the fingerprints of dark energy, NASA is charting how fast the horizon recedes. Each dataset reveals a universe larger than imagination, yet increasingly hidden from view. It is as though creation is pulling its curtain back, leaving only fragments of the play visible on our cosmic stage. The galaxies beyond the horizon are not lost. They are simply unreachable. Their light will never arrive, their stories never told. Still, their existence shapes the whole, influencing the gravity and flow of the universe we can see. NASA's findings remind us of a humbling truth. Our vision, even stretched with telescopes, is finite. The cosmos continues beyond us, silent, immense, and filled with secrets light will never deliver. In the late 1990s, NASA astronomers studying distant Type Ia supernovae uncovered a truth that rewrote the story of the cosmos. These exploding stars, used as standard candles to measure distance, revealed that the expansion of the universe was not slowing as once believed. Instead, it was accelerating. The discovery pointed to an invisible force, an energy woven into space itself that drives galaxies farther and farther apart. This unseen power became known as dark energy, and it changed our understanding of cosmic destiny. NASA's surveys of galaxies and clusters added to the evidence. By measuring the distribution of matter and the subtle imprints left on the cosmic microwave background, scientists confirmed that dark energy is the dominant component of the universe. Nearly 70% of all that exists is made not of matter or light, but of this mysterious force. Though it cannot be seen, its fingerprints are unmistakable in the way space stretches, in the redshift of galaxies, and in the fading of the observable horizon. The implications are profound. If dark energy continues its work, galaxies will drift so far apart that each will become an island in endless darkness. The night sky of the far future will no longer glow with thousands of galaxies, but only with the stars of the local group, until even those fade beyond sight. The universe will grow colder, quieter, and more isolated, stretched thin by the relentless push of expansion. NASA's data revealed not only the presence of dark energy, but also the outline of time's ultimate course. Yet despite its dominance, dark energy remains one of science's greatest enigmas. Is it Einstein's cosmological constant, a property of empty space itself? Or is it something dynamic, a field that changes over time, altering the fate of everything? NASA's missions, from Hubble to the upcoming Nancy Grace Roman Space Telescope, are designed to probe this mystery with greater precision, measuring how dark energy has influenced expansion across cosmic history. Each dataset brings us closer to understanding, yet the nature of dark energy remains elusive. The discovery turned what was once mystery into destiny. Without dark energy, the universe might have collapsed back on itself in a fiery end, or coasted quietly into balance. With it, expansion is assured, written into the structure of space. NASA's observations transformed scattered supernovae into signposts of fate, each one pointing to a future where the cosmos continues to widen, carried by a force we cannot yet define. Dark energy is a reminder that the universe is not ruled solely by what is visible. Its greatest influence comes from the unseen, from a presence that cannot shine, yet dictates the fate of galaxies and time itself. NASA revealed this truth with patient vision, showing that the end of the universe is already inscribed in its expansion, a destiny carried silently in the mystery of dark energy. The universe has an edge of vision, a horizon drawn not by walls but by time itself. NASA's telescopes have pushed that horizon back more than 13 billion years, capturing galaxies from the universe's infancy and mapping the afterglow of the Big Bang. Yet even at this limit, there is more beyond. Light has simply not had enough time to reach us. What lies outside remains hidden, a realm where science turns from measurement to imagination. Cosmological models attempt to sketch what might exist past the observable boundary. Some suggest infinity, a universe extending without end, filled with galaxies repeating endlessly beyond sight. Others propose that our cosmos is only one bubble in a vast cosmic sea, each bubble governed by different physical laws. This idea, called eternal inflation, imagines new universes budding constantly, their expansion forever creating fresh horizons. NASA's discoveries cannot confirm such visions, but they shape the frameworks in which such questions are asked. The maps of the cosmic microwave background provided by NASA satellites like WMAP and Planck show a universe remarkably uniform, with only tiny fluctuations in temperature and density. This smoothness is consistent with inflation, a period of rapid expansion in the earliest fraction of a second. If inflation occurred, then our observable cosmos may be just a small patch within something far larger. In this way, NASA's precise measurements give the limits of what we know and suggest the possibilities of what we cannot see. Yet speculation is guided by data, not freed from it. The faint ripples in background radiation, the redshift of galaxies, the clustering of matter, all are landmarks that tether imagination to evidence. NASA's observations act as boundaries, as if drawing the map of a coastline, while the vast ocean beyond remains uncharted. We know the edge, but not what lies past it. Theories of infinity and multiverses rise from this boundary, tested against the contours that NASA's instruments so carefully traced. For the listener, this is where science meets wonder. The universe we can see is immense beyond comprehension, yet still finite in reach. Beyond it may lie endless repetition, or entirely different realities, or perhaps nothing at all. NASA cannot pierce that veil, but its discoveries show us exactly where the veil falls. The edge of the observable universe is not the end of creation. It is simply the end of vision. Here, questions begin. The data invites them, and imagination extends them. NASA has given us a cosmos rich with detail up to the very brink of sight, and beyond that brink stretches possibility. It is a reminder that discovery does not remove mystery, it refines it. What lies beyond what can be seen may never be answered, but the act of looking has already transformed the horizon from emptiness into wonder. At the farthest limits of sight, NASA's telescopes have reached back across almost the entire age of time. Hubble first revealed galaxies so distant their light had travelled for more than 13 billion years, tiny smudges on its deep field images that were already ancient when Earth was unborn. Then the James Webb Space Telescope, with its golden mirrors and infrared vision, pushed the boundary even closer to creation. It uncovered galaxies formed within the universe's first few 100 million years, shining when darkness had only just begun to break. Their faint glow, stretched into long red wavelengths, carries the memory of a cosmos still in its childhood. Alongside these discoveries lies the cosmic microwave background, mapped by NASA's earlier satellites. It is the oldest light of all, released when the universe was only 380,000 years old. Together, Webb's galaxies and the microwave background define the true horizon, not a wall at the edge of space, but a boundary in time, set by how far light has been able to travel since the beginning. To look outward is to look backward, each step carrying us closer to the moment of birth. What NASA found at this edge is both humbling and profound. It is not silence, but memory. In the faintest galaxies lie the stories of the first stars, blazing fiercely and quickly, seeding the cosmos with the first heavy elements. In the afterglow of the Big Bang lies the blueprint of structure, ripples that would one day grow into galaxies, clusters, and the web of the cosmos itself. These are not just scientific findings, they are glimpses of our origin, written in the oldest light still arriving at our world. The edge is not an ending. Beyond it, the universe continues, though its light has not yet reached us and perhaps never will. What we see is a horizon, a boundary of perception that expands as time passes, allowing new light to arrive, but forever leaving more unseen. NASA's instruments gave shape to this horizon, showing us the cosmos as both immense and intimate, endless yet knowable in part. In the deep silence of space, NASA revealed the universe as a child, galaxies flickering into existence, stars kindling their first fires, light escaping into the open for the first time. It is a portrait of beginnings, carried across eternity and received by mirrors and detectors orbiting a small blue planet. The discoveries remind us that we live not apart from this story, but within it, made of the very elements those early stars forged. At the edge of the universe, NASA did not find a boundary of endings, but a threshold of memory. Written in light and preserved across billions of years, it is a record of how everything began. To look there is to gaze into the mirror of creation, where time's first moments still shine, whispering that the universe remembers, even when we are only beginning to understand.